All right. So we continue from where we ended last time, which is on question 2. Okay. So we were solving inequalities questions. So and we ended on question 2. We're supposed to start from there. Okay. So now when you're solving inequalities, you need to understand that there's a point where you have to find critical points, and then from there you test the solutions and get the solutions that satisfy the what? The inequality. Okay. So for the second one here, we have 1 over x squared minus 2x minus 3 is less than or is greater or equal to what? To 0. That is our inequality. Okay. So here we need to this one is a factorizable quadratic function. Okay. So we can just say that, okay, let us factorize what is at the bottom. And we're going to say that this is going to be 1 over, what's the product here? The product is equals to negative 3. Yes? The sum is equals to negative 2. Okay. So the sum is equals to negative 2, and the product, the factors. Name two numbers. When you multiply them, you get negative 3. When you add them, you get negative 2. Those two numbers are just, the factors are negative 3 and 1. Okay, those are the two factors. So as a result, you're going to have x squared, okay, minus 3x plus x minus 3, because we're getting these factors and replacing them on the value which are the sum, okay, which is negative 2x, such that these two values, when you replace here, you don't change anything. It is just another way of writing it. Okay, then you're going to have this. Okay, as a result, you're going to have 1 over, what's common here is x. Okay, x open brackets, x into x squared, that would be x, then x into negative 3x, that would be minus 3. Then what is common here? It is plus 1. Then in here it's going to be x minus 3. Okay, it's greater or equal to 0. Then you get what is outside, because what is inside the brackets, it is the same. So you just pick 1 and you get what is outside. As a result, you're going to have an inequality which will look like this: 1 over x plus 1 and x minus 3. Okay, is greater or equals to 0. Now, when you reach this point, here you're already close, because you have the numerator and you have the denominator. Because the only thing you can do here, it is to find critical points. Okay, so the critical points, you just equate these equations. For example, x plus 1. Okay, x plus 1, you equate it to 0. If we had another one, for example, if we had 2x plus 3, even here, we would have equated the numerator as well to what? To 0, to find the critical points, because that is necessary. So as a result, our x is equals to negative 1. Again, we equate the x minus 3. Okay, because these are critical points, because they are the ones which can even make the function to become what? Undefined. So that's why they are critical points. Okay, so the other one, you equate this one to say x minus 3 is equals to 0. As a result, your x is equals to 3. Okay, so that is your x. So these 2 points, x is equals to negative 1 and x is equals to 3, they are critical points. Okay, so as a result, you're just going to go here. You found out that x is equals to negative 1 and x is equals to positive 3. So when you're testing these solutions, you're just going to say this. Okay, you write this, then you write this, then you write -1, the smaller one, then you write positive 3, the bigger one. Okay, then here you just create some space for equations. Okay, that's to be like this. So now you get the first equation, which we have x plus 1. Okay, and you're going to plug it in here, x plus 1. Then you're going to get the other one, which is x minus 3. Then you're going to get now the entire equation they gave us, which is x plus 1, x minus 3. Okay, so this is the entire. So we are going to see how it will be behaving. Okay, if it's going to be negative, if it's going to be positive or negative. So we know that from here it's from negative infinity to -1. Okay, then from here it's from -1 to 3. Then from here it is from 3 to positive infinity. Okay, so now you start testing this equation. You say x plus 1, when you plug in a number that is between negative infinity to -1, how is the equation behaving? Okay, or how is this expression behaving? So for example, if I was to get -2 and I plug in on negative, so on x plus 1, it will be what? It will be negative. Then if I was to get a number between -1 to 3 and plug it in here, I'll get what? I'll get a positive value. Then if I was to plug in a number which is between this, I'll get a positive value as well. Then if I was to test x minus 3, I plug in a negative number here, I'll get what? I'll get negative. Then if I was to plug in a number between -1 to 3, I plug it in here, for example 0, I'll get what? Negative. Then when I say 3, uh, between 3 to infinity, which is 4, if I plug it in here, I'll get what? I'll get a positive value. Then now, looking at these two equations, or these two expressions, they are multiplying. Okay, so this times this, it will give us what? Positive. You can check down here, they are multiplying. This times this, it will be what? Negative. This times this, it will be what? Positive. Okay, so now when you reach this point, because this value here is what? Is positive as well, so meaning that the effect of the denominator will also affect the numerator. Okay, so now the question was telling us that we're supposed to find an inequality where uh, this inequality must be greater or equal to what? To 0. So meaning that the solution must be those values that are giving a positive answer, which is uh, this one here and also this one, not this one, because this one is giving us a less than 0 answer. So meaning that our solution will be between negative infinity to -1, and also between 3 to what? To infinity. Okay, so infinity is a symbol, so you don't include it. Okay, then now you go on -1. What symbol? Oh, you go to these two interval notations. Then you ask yourself, how am I going to represent them? Okay, how am I going to show them that these two points are giving us values? So we unionize it so that we combine these two solutions. Now, do we include the -1 and do we include the 3? So the determining factor which will help you to include the -1 and 3, it is the symbol that they've given you. For example, here they've given us less than or equal. So when they just write or equal, or they've written greater than or equal, as long as they've just written or equal, meaning that the solutions, these ones, are going to do what? To be included. Okay, and this is your set solution for that question. Are we together? So you are free to ask where you've not gotten. Is it clear? I didn't get you.
Yes, sis.
All right, all right,
Clear.
all right, all right, all right. Thank you very much. Okay, so that is your set solution. Now, let us go to modulus functions. Okay, how to sketch modulus functions. Okay, so I'm sure we know what modulus functions are. Okay, so this question is not specific to say let's just sketch the modulus function. No, it is telling us about redefining the modulus function which they've given us, okay, and sketching it for the second part. So this was more like 3 marks and 5 marks, altogether somewhere 8 marks. Yes. So we need to redefine it and sketch it. Probably it was even maybe 3 3 like that. So it is a very important question. They might ask you because uh, if I didn't see it in your tutorial sheet, but maybe it's there, but maybe I didn't pay attention, but I didn't see it. But uh, regardless of the situation, you learned about modulus functions, isn't it? So you can just give me a thumbs up if you learned modulus functions and how to sketch them. Okay. So they are a very important piece of your test one. They can ask you about sketching them. Okay. So you need to understand how you're supposed to sketch these modulus function. Okay. So the common ones are those ones where they just say, okay, they will say maybe sketch f of x is equals to uh like this, then they tell you to sketch. Then you know that you define this to say, okay, this one can be redefined to say that, okay, it's going to be negative x when x is less than 0. Okay, you're going to say this. Then you're going to say that, okay, it's going to be x when x is what is is greater is greater or equals to 0, like that. Then you just say, okay, you write this line, then you say, okay, this is our x. So when x is less than or equals to 0, uh, it will behave negatively. Okay, so meaning when you plug in a negative value there, it is going to be giving you a positive solution. For example, when you plug in 0, because 0 is part of this one, so 0, it will be here, and then -1, you find out that here it will give you a 1. Okay, when you put -2, it will give you -2. Okay, when you put -3, it will give you +3. Then when you go to the positive side where x is greater or equals to 0, it is going to give you, for example, when it's 1, it's going to give you what? It's going to give you 1 as well. When it is 2, it will give you a 2 as well. Okay, so this one, there is a point where you write a O because this one is not included for 0 for the other part. Then for example, here there's 3, it will be a 3 here. So you're able to see that modulus functions, they are more like this. Okay, you see something like this because a modulus can never give you what? Can never give you a negative solution. So that is why all these things come about. Then unless if there was a negative outside, meaning that it would have spinned, then it would have looked like this. That is what is going to happen. Okay, so just be vigilant of these modulus functions, because they are very important. Okay, very, very important. Okay, so now let us go to our question of today. So our question for today is saying that redefine the modulus function I. Okay, f of x is equals to 2x minus 1. Okay, minus x plus 2. Okay, so I want you guys to be participating in this question so that you can get it and understand it here and there in the class. Okay, so now the first question is asking us to redefine this modulus function. Okay, so now here the first thing that you're going to do, because you have two modulus functions, okay, you're going to separate them. Okay, you get the first one, which is 2x minus 1. Okay, then you redefine it, and you get the other one, which is x plus 2, and you also redefine it. Okay, so from the first one, what points are you going to get? For the first one, when you redefine it, what are you going to get? Okay, so when you redefine this one, you're going to get if it is behaving positively. Okay, because your goal it is to see if it is behaving positive, because a modulus can never give you what, a negative solution. Okay, so now, because a modulus can never give you a negative solution, let us check for the first one if it is behaving positively, meaning that there won't be any multiplication of what, of negative in front. Okay, so meaning that it's going to be 2x minus 1 if, okay, if x is what, is greater than or equals to what, to 0. Okay, so if x is greater or equals to 0, we are going to have if x is greater or equals to 0, we are going to have okay, but in this case let me not say 0. Okay, so 2x minus 1 uh if 2x minus 1 is what, is greater than 0. Okay, if 2x minus 1 is greater than 0 or equal, okay, that is when it is going to be what, that is when it is going to be like this. Then we are going to say that negative, if it is behaving negatively inside, we multiply with a negative so that it can cancel that negative, so that the solution can be what, can be positive. So if it is behaving negatively, okay, we're going to say negative, okay, negative 2 negative 2x minus 1 if 2x minus 1 is less than 0. Okay, that is what we are going to get. Then for the next one, you're going to say that x plus 2 if x plus 2 is what? Is greater or equals to 0, because that is what satisfies this modulus function. Now, if x plus 2 is, let me say, it's negative x plus 2, meaning it's behaving negatively, this will only be possible if x plus 2 is less than 0. Are we together? Are we together, everyone? All right. Thank you. So after we define like this, we're going to say, okay, we started the first one. The first one is going to be 2x minus 1, which we've redefined this to be 2x minus 1 if so we're going to solve this part. So you know that when you solve this part, it's going to be 2x. You take the 1 this side, it's going to be 2x is greater or equals to 1. You divide by the 2, which is positive, so meaning that the sign won't be affected. It will be x is greater or equals to 1 over 2. Okay, so meaning that this side you're going to have x is greater or equals to 1 over 2. So that is what I'm going to say. If x is greater or equals to 1 over 2, that is what you're going to have. Now, if it is going to be negative reacting, you multiply the negative to this, you're going to have negative 2x plus 1. Okay, so you're going to have negative 2x plus 1 if the solution, the calculations we've done them. Okay, it's going to be x is less than 1 over 2, because this one, it is less than. So when you take the 1 this side, then you divide by 2, it's going to just be less than 1 over 2. Now you go to the next one, x plus 2 if x plus 2 is greater than is greater than or equals to 0. So this is just telling us that uh, this other one, which is x plus 2, the modulus of it, it is only possible if x plus 2, if x is what? Is greater or equals to negative 2. Then the other one is you multiply the negative with it, because you can check here. You multiply the negative with this, and with the 2, it's going to give you negative x minus 2. So it's going to be negative x minus 2, comma, if x is what? Is if x is less than negative 2. That is what you're going to have. So now you are redefining. Okay, so this is telling us that now when you have 2x minus 1 modulus minus x plus 2, when you are redefining this function f of x, okay, you are going to say that this is equals to, you are going to write this. Okay, so when you write this, you start with those ones which were, you combine them because you're subtracting. Okay, you're subtracting expressions here. Okay, so now here you're going to be picking from this. You'll be picking because here you have this one is modulus, it has two equations, or let me say two possibilities. Okay, then even this one, it has two possibilities, but we have to combine these two modulus functions. And it is more like the way you solve physics, you say that x components can only add with the x components, and y components can only add with the y components. That's in physics when you're dealing with vectors. So in this case, those values that are greater than a certain number, those two equations, they can subtract or add. Okay, for example, they say that both of them, they are greater or equals to 1 over 2. Those two equations, they can do what? They can add from these different. So from 1, from here, if it is equivalent to also something which is here, they are both greater, they can subtract or add. So in this case, I'll start with the first one. The first one is saying that 2x minus 1 is only possible if x is greater than 1 over 2. So I'm going to say that so 2x minus 1, if it is greater, okay, if it is greater, so it's more like I'll be intersecting, okay, if it's greater or equals to 1 over 2. Okay, now when I go to the other modulus uh, expression, I'll come here and I'll say I'll go to the first one. If x plus 2 is only possible if x is greater than negative 2. So it's more like there is negative 2, there is negative 1, there is 0, then there is half. So this one also includes a half, okay? So meaning that these two, they can do what? They can subtract, okay? Because of an intersecting region which is half. So meaning that it will be 2x minus 1, then you say minus, okay, minus this minus which is here comes in now because you are defining 2x minus 1 minus, you get the first because this one also includes a solution which is this, okay, so you put those ones which are intersecting. So as a result, you're going to have minus x plus 2 if x is what? Is greater or equals to 1 over 2, because that is the region that is satisfying for both of these uh, expressions. Are we together? Are we together, everyone? Can you just give me a thumbs up so that, all right. So I should be seeing that everyone is following. Okay. So now I'll go to another one, which is so let me check another one. So there is a point where so here, let me check negative 2 x plus 1 if x is less than 1 over 2, okay, is less than 1 over 2. And then this one, another one here is saying that x is if x is less than negative 2. So you know that these two can subtract because there's a region. If I say x is less than 1 over 2, meaning that it's coming from negative infinity to 1 over 2. Okay, that is what I mean. So now there is a region because negative infinity to 1 over 2, there is a point where it's going to reach negative 2. Okay, so I'll get these ones here. I'll just pick them. Which is this one, because they are, I'll write it at the end. Okay, I'll show you why I'm writing it at the end. So I'll get this component here, which is negative 2x plus 1, okay, minus, okay, there's another region which is so this one which is negative x minus 2 if x, so I'll get the one which is common for both, which is negative 2 when x is what? Is less than negative 2. So I'm going to get that. Now, there are two equations which are supposed to also subtract because there is a point where there's a point, for example, this one is less than 1 over 2. There's a region. So it is like this. This is 0, right? Then this is 1 over 2. Then this is a number line, okay? Then this is negative infinity. Then from here to this side, okay, there's a region. Then again, from here there's negative 2 now, okay, from negative 2 again here going this side, there is also a region, okay, this region again going this side. Now there's a point where they said that x is here, x is greater or equals to negative 2. So meaning that there's a point which is also accepting this region here, okay, because there's a point which is x is greater. Then again, there is the one which is x is less than 1 over 2, which is also covering, making these two to do what? To intersect. So they are also, so the ones for here, we've already done them. This one, when it is less than negative 2, we've gotten the two equations, which are these two. Then the ones for the positive side, for example, when it is going this side and another one is going this side, we've already gotten those ones, okay, which is the first one we got. Now, but there's also a region which is also intersecting here on the middle, okay, which is saying that it is between x is greater or equals to negative 2 and x is less than 1 over 2. So meaning that it is a region between, to say, if x, oh, let me not say x, so if negative 2 is what, if negative 2 is greater, oh, sorry, if x is greater or equals to negative 2, then also x is what, is less than 1 over 2. Okay, that is the region which we want. So now we pick these two equations. For example, we have we have negative 2x. So this is the first, for the first part. So we're going to get that one because it is the first part. So it will be negative 2x plus 1 minus. Then I'll get the other component, which is this one, which is saying that it is greater or equals to what? To negative 2, which is covering that, which is what? X plus 2. So I'll say x plus 2, like that. Are we together? Are we together, everyone? Is it clear what I've done here? So I just want to be getting feedback. That's why I'm asking. Because of the network, it might trip. So I need to make sure that you are able to get me. Is it clear, Precious? Justine, is it clear? Or maybe you have a question on it.
I was kind of asking if you can repeat on the equation on the middle part.
Okay. All right. So now let me repeat. Uh if you check very well, the first one we got, it was we said that 2x minus 1 minus x plus 2, because these ones were satisfying a certain region where x was greater or equals to 1 over 2. Okay, so we got the first one, which was x is greater or equals to 1 over 2. And we know that it is a region starting from where? From here, oh, going this side. Sorry. It is a region starting from here, going this side to what? To infinity. Okay, that is the region which we knew. Then again, they were saying that there is another region which is greater. Okay, there is another region which is greater or equals to negative 2, meaning that it is starting from here, it going to what? To infinity. So those two regions, they were intersecting at this region. Okay, so because they were intersecting at this region, I'll just get them because they are also including some values that are in both, because that is where it is very important. So I found out that those two were, it was the first one and the first one of this one. So I got them. Okay. Then now I also found out that there is also a region which is between, so let me just draw a new one here. So I have 0, I have 1 over 2, I have negative 2 here, okay? Then I have negative infinity. Then I have positive infinity. So there is another region. So this one now I'm talking about the one which is here. There's another region at the bottom. For example, this was negative 2x plus 1. X is less than 1 over 2, meaning that here where there is 1 over 2 going this side, okay, that is where this one is. Okay, again, this one is saying that x is less than negative 2. So you go negative 2, okay, then you go down like this. So now you also find out that they are intersecting at this region. So because they're intersecting, they are going to subtract these two. Okay, so you've got, I also got them, and they are the ones I wrote at the bottom. Then I'm going to get the one which both of them are starting from, which is what? Negative 2, and that's what I wrote, x is less than negative 2. Then the one on top, I got the one where they were starting from, which is 1 over 2. So I said x is greater or equals to what? 1 over 2. Okay, that is what I got. So now I went to a part now where I said, you've seen that here down there is this space, okay, and it is for an equation which is what, which is less than 1 over 2, which is this one here. Okay, there is that region there, this region which has been written but it has not been catered with. But again, here there's another region here. You can check it, and it is for the equation which is starting from negative what? Negative 2, where x is what? Is greater than what? Or equals to what? To negative 2, which is this equation which is here. Okay, so meaning that these two expressions, they can subtract because they are causing themselves to do what? To intersect at this region. Okay, so because of that, that's why I got this one for the first modulus expression, and I got the other one from the second, which is this one here, because these two, they are causing a reaction here. Let me just say a reaction on the middle here because of what has been left. Okay, this one left this region, and the other one also left a certain region at the bottom. As a result, because of that, that region was intersecting, so it had its own equation. Are we together?
Yes, sir.
Yes. So I'm sure this one you can write it as don't know if I've written it the correct way. I don't know if this one's supposed to be this side. I think it's fine, right? Yeah, I think it's fine. It's fine. Okay. All right, so that's why they were subtracting. So now I'll just start simplifying them. Then I'll just say that, okay, in this case we have f of x being equals to the first one there on top, which was 2x minus 1, is going to be minus x minus 2. Okay, because the negative is going to multiply with everything here. So it's going to be 2x uh, 2x minus 1 minus x minus 2. Okay, if x is what, is greater than 1 over 2, greater or equals to 1 over 2. Then again, here at the bottom again, we're going to have here negative 2x plus 1 minus x minus 2. So it's going to be negative 2x plus 1 minus x minus 2 if x, oh, if negative 2 is less than or is greater or equals to x, or is less than 1 over 2, that region. Then again, the other one, which is negative 2x plus 1 minus, so it's going to be, this one's going to be plus, so it's going to be plus x plus 2. Okay, so it's going to be plus x plus 2. Okay, then this one is x is what? Is less than, is less than negative 2. So this is the redefined, the new expressions that have been redefined. As a result, f of x is going to be equals to, this one is going to be 2x minus x, it will be x. Then negative 1 minus 2 is going to be minus 3. Okay. Then if x is greater or equals to 1 over 2, then you're going to say negative 2x minus x is going to give you negative 3x. Then positive 1 minus 2 is going to give you minus 1. If x, oh, I don't know how I'm writing this, negative 2, if negative 2 is greater or equals to x less than 1 over 2, like that. Then this one at the bottom is going to be negative 2x plus x, which will be negative x. Then 1 plus 2, it will be plus 3. Okay, if x is less than negative 2. So now you have redefined the modulus function and you get your 3 marks. Are we together? Okay, so that is on redefining. Now, after you've redefined, they are telling us that now we are supposed to do what? To sketch, okay, the function f. So when you're sketching the function f, you're going to say that 2, okay, you write this, okay, the Cartesian plane. When you write the Cartesian plane, you're going to start with the 1 on top, okay, x minus 3. So now when you are sketching modulus function, you need to understand that not all functions are working for the entire Cartesian plane, okay. They are working based on the domain they've been given. So the domain is this one, which is here. So this function, or this function x minus 3, is only going to work for a region that is x is greater or equals to 1 over 2, which is a region, so here I have 1 over 2, okay, so I have 1 over 2. So it's only going to work for this part, not this part, which is this side. So meaning that when you're sketching, you're just going to say that x minus 3, you start testing, because when it is 1 over 2, okay, when x is greater or equals to 1 over 2, you yes, okay, so it's only going to work for a region that is greater or equals to 1 over 2. So now you start testing. uh Greater values, let me say you have x is what, x is let me say x is, so here I have half, then I have 1, 2, 3. Okay, so you find out that the modulus function, uh when you start plugging in these values on x minus 3, so on x minus 3 you're going to start plugging in, because the solutions that are working for this one are those ones which are greater than 1 over 2. So meaning greater or equal. So meaning that you, when you plug in 1 here, you're going to get what? You're going to get a negative what? Uh, so here you have 0, you have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay? Going down. When you plug in half, you're going to get an answer which is just below here. okay, it will just be below here. For example, so it will be 1 over 2. So it will be an answer which will be negative 2.5. It will be just somewhere here. Okay, when you plug in 1, it will be negative 2. When you plug in 2, it will be negative 1. When you plug in 3, it will be 0. Okay, and you're able to see that this one, it will be going like this. Okay, it has already shown you where it is going. So it is going like this. You're just sketching. Then now, when you have covered, because this is the point you're supposed to end with that function going, so you just write an arrow to show that it is going this direction. So this one is for x minus 3. Then now you come back, you go back to the other one now, which is working between, it is working between negative 2.5. Okay, it is working between negative 2.5, and that one, it is what? It is negative 3x minus 1. So we go to negative 3x minus 1. So now that is where, so when I plug in 1 over 2 there, I am going to get a wall, because I'll get the same value which I got when I plugged in what? When I plugged in half. Okay, I'll get the same value which I got, but this value, remember, 1 over 2 is not part of it. You can check, it doesn't have a bar, so meaning that it is not part of it. So meaning that you're not supposed to include the solution when you plug in the half of, when you plug in half into this. Okay, you're going to write a circle around it to show that. So you just write a circle around it. Then after doing that, you start plugging in now values that are between, negative 2 and what? And half. So I can get 0. So when x is equals to 0, what is the value of uh what is the value of this function? Okay, so when I plug in 0 here, I am getting negative 1. Have I gotten the correct one? Is it minus? Okay, yes. So it's going to be negative 3x minus 1. So when I plug in 0 here, I'll get a value which will be here. Okay, it will be negative 1. When I plug in negative 2, the same negative 2, when I plug it in here, I'll get negative 2 when I plug it in. So I have negative 1. When I plug in negative 1 here in this function, I'll get positive 2. So I'll get a value which is just above here, 2, 1. So I'll get positive 2. Okay, a value which is here. When I plug in negative 2, I am going to get a value which is 5. I'll get 2, 3, 4, 5. I'll get 5. Okay, I'll get a value which is here. Okay, so after getting a value which is here, and now do I check here negative 2, is it included in this equation, in this function which I'm using now? Yes, it is. So meaning that I won't draw a circle there. Okay, so I'll just write like this. Then I'm just going to connect these points. I have that. Then now it has to be straight line, just that I can't draw a straight line here because of, yes, it has to be a straight line like this. Even this one is a straight line because these are straight lines. Okay, then now you go to the last function. For the last function, you plug in values that are less than negative 2, meaning that you start plugging in negative 3, negative 4, negative 5, all those values. Okay, as a result, you're going to get, you go back here, you start plugging in negative 3. When you plug in negative 3 in this new function, which is negative x minus 3 plus 3. Okay, it's negative x plus 3. So when you plug in negative 3 here, when you plug it, let me start with the where it ended, that one where it ended, because that's why this one is starting. So I'll go negative 2. When I plug it in there, I am getting the same 5. Okay, so but this 5 won't be included in this function. I'll draw a circle around it to show that there is a hole, because here it doesn't have a bar. Okay, it doesn't. So meaning that I'm not going to include it, because when I say negative 2 plus 3, I'll get the same 5, but I'll not include the 5, okay, because the value I've used is not part of the solution. So I'll write a circle. Then now I'll start getting values which are less than negative, which is negative 3. When I plug in negative 3 there, I am getting 6. Okay, so I'm getting values which are on top. So I'll get 6, I'll get 7. So when I go to 3, negative 3, I'm getting a 6. When I go to negative 4, I am getting a 7. Okay, I've already seen that this graph is going this direction. As a result, this is the graph of f of x equals to 2x minus 1 minus x plus 2, and you're done with your solution. Are we together?